back. Right, so basically the first thing we do here is we set up the circuit exactly as we've drawn it. So I have the power supply here, I have the potentiometer sitting here, I have my my coil with water here. I think the ammeter goes this side, doesn't it? It doesn't matter, okay, I'm just trying to keep it similar to the other one. And with the voltmeter, I'm just going to leave the voltmeter on this side of that rather than the other, but effectively the same setup, right? And that makes it easy to wire. Okay, so it's the other way around, it'll be easier, right? So the two ends of the potentiometer, okay, connect to the plus and to the minus of the supply. Okay, so I'm putting the plus on the left here, okay, and I'm putting the right, or the minus on the right. Okay, so plus, minus, right? That's that. Okay, and I put that in red because when I drew it earlier, I had it in red. Okay, I'm then going to go from the middle. Okay, remember the middle is this connection up here. I'm going to go from the middle to the ammeter. Okay, so it doesn't really matter, but I'll go from the plus to the minus. Okay, the ammeter, and then from there I'm going to go into the coil. Okay, so sorry I didn't show you this. This is just a coil in water. Doesn't appear like a coil, but inside that ceramic block is a metal coil. Okay, and it's in water to keep it at a constant temperature. We want to do the experiment reasonably quickly so that the water doesn't heat up, doesn't rise in temperature too much, because we want it at a constant temperature. It won't heat up very much in the time we'll be at it. Okay, I'm going to connect this to this. Okay, I'm going to have that voltage there at about just over 7, so we want to go up to 7. Okay, actually, hold on a sec now. Oh yeah, that's fine. Okay, and this connects then to this end of the resistor, to the base of the resistor, okay, which is there. Okay, so with that set up, okay, and we have a current reading there. Okay, that's fine. And the last thing we want to do is we're going to connect the voltmeter across both sides, and as with our diagram earlier, I'm going to use blue. It's very colour coordinated today. You won't be as colour coordinated when you're doing it. Okay, so we won't have enough colours. Right, okay, so I'm going to connect that to here and this to here. Okay. Okay, and you can see we have a voltage reading. Okay, so I now just need to reduce this down to get it to 1 volt. Okay, so I'm just reducing this down until I get that to 1 volt, approximately 1 volt, and you're taking your reading. Okay, can everybody see the reading? Sorry, not very clear. Okay, so I've got that. Okay, so it's clear now. Okay, so I'll read that one for you. Okay, take it out, make this clear. Okay, about 0.43, don't matter, fluctuation. Okay, take a reading. Okay, so 1 volt, and that's your reading, 0.43. Okay, we're going to move it to 2 volts. Okay, so I'm just moving it up until it gets to 2 volts. Okay, and you're taking your reading. All right, 3 volts, you're taking your reading. Okay, 4 volts, you're taking your reading. 5 volts, you're taking your reading. 6 volts, you're taking your reading. And 7 volts, you're taking your reading. Okay, so you have all your readings taken. Now you're going to draw a graph of voltage against current. You do expect this to be a straight line graph through the origin. Assuming you get a straight line graph through the origin, remember, draw your line of best fit and so on. As long as you get a straight line graph through the origin, I want you to indicate why it obeys Ohm's law, okay? And I want you then to get the resistance of the coil using the fact that the slope is equal to 1 over R. Alright, so you get the slope first, and then you get the resistance. Okay, so that's the work for you. Okay, thanks a minute.